Today's video, we're going to be doing an exploratory data analysis. And for this analysis, you're going to be using data from hotel booking data. So this data from hotels and booking information. So we're going to be using that in the exploratory data analysis. In machine learning, as you know, exploratory data analysis is quite important component in that pipeline of machine learning, because you need to understand your attributes before starting building your machine learning model. So to learn more about your the attributes of your data, then you need to do an exploratory data analysis, and from there you can maybe select the most important attributes that may or may not greatly impact the functionality of the model that you're trying to build. So basically, that's what you're going to be doing, and we're just going to be focusing on the element of exploratory data analysis. And as I said, you're going to be using the hotel booking data for this analysis. You're going to use that and maybe see what insights or conclusions that we can draw from this data set. So before we get started, please consider subscribing. We are welcoming you to this wonderful community. Hit that notification bell so that you never miss any of our video updates. You can also like this video, and if you have any suggestion, any comment, you can drop them down in the comment section, and I'll do my best to get back to you. So with all that said, let's get started and probably see what we can derive from this data. Okay, so I'm going to start. As I said, this data set contains booking information for city hotel and a resort hotel, and includes information such as when the bookings were made, the length of stay, the number of adults, children, among other things. So it's very ideal for exploratory data analysis, or when you want to start or get started in building your predictive models. Okay, so let's start. So as usual, we are going to start by importing the necessary modules or the necessary libraries. So for the libraries, remember this is an exploratory data analysis. So we are going to be, it's going to involve a lot of visualization, a lot of charts, visualization, all that stuff. So despite the normal pandas and the numpy, we're going to include the libraries that we oftenly use for visualization. Okay, I'm going to start by let's import libraries. So here I'm going to pandas speedy. You can also import numpy. It's NP visualization. You can include the matplotlib library. Matplotlib. Okay, that's okay. Pyplot. Also import Seaborn. Plus Plotly. So basically, those are the libraries: pandas, numpy, matplotlib, Seaborn, and Plotly. So those are the libraries. Then after that, we need to connect to our is now connected. Okay. So for this, I'm not using a Jupyter Notebook. I'm using Google Scholar. So be mindful of that. So then after that, after this, we can then import our dataset. So for the dataset, import. Basically, I think by now you you are aware or you have a full understanding of these common activities like importing the libraries. Oops, getting some error. Let me see. Probably what we are missing is that I did not mount into the Google Drive. That we can use this function to read our data. So data drive, I think now it's okay. So let me execute this again. Now we are good. Now we are good. Okay, so after that, so we have imported the libraries, and after that we have imported the dataset. So this is the dataset that we are going to be using. And after this, maybe a little bit of data summary, just to have overview of your data. And then from this, you can see we are dealing with a total of 32 columns. These are the columns. In terms of the number of entries, 119,000 entries. Basically, those are the number of rows in the data frame, and you can also see the data types for the values in these columns. So I'm using the term column interchangeably with attributes. Okay, so don't get confused about that. So column attribute, almost the same thing. Okay, so we have loaded our data. Now we can now see the columns, the data type. One thing that you can see or you can observe with the data is that we are missing some column. We are missing some data in some columns. For example, column country, you can see that we're missing some values. Then for the column, you can see company, we're also missing some values for this column. So to just do a quick we can sum all the sum of the null values in each column or attribute. Then you can see the column country, we are missing some we're missing 488 values. For the agent company, you can see the number of values or we are missing in those columns. Okay. So after this, just jump directly into data cleaning. You can see we are dealing with a lot of inconsistencies now in our data. So let's move to data cleaning. So from here we can try to remove these inconsistencies and try to make our data as clean as possible, so that when we start doing the exploratory data analysis, we are going to be precise as possible. Okay. So the first thing that I will do is that I will just, for these columns, you can see the country, agent, company. What I will do, we're also missing data from the column children. So what I will just do is that I will drop these columns that we are missing values. Okay, so just drop them. There are other ways you can use to correct this. For example, you can use imputing with a given strategy, mean or the most frequent value in those columns. Then from there, you can fill these empty values. But for my case, I'm just going to drop them. When dropping, when dropping this, I'll use the drop function. Let me try to change it. Say something else. High contrast. Let's use this. So for data cleaning, I'm using the drop function. And in the drop function, you can I've specified the columns. So in the drop function, I'm passing in a list of the columns that we're going to drop. When I execute this, let me just execute that using the same null, so that we can, when we run this, you can see we're getting zeros. That means we are not missing. We have dropped those columns with missing values, and we don't have any column or attribute that is missing value. Okay. So another step, another observation that we made was for this column. When we or another thing that we can do, we have these columns: arrival date year, arrival date month, and arrival date day of month. So basically, when you look at that, you can see that arrival date here basically is just telling us the year that the customer arrived. Then arrival date month, basically this information is just telling us about the month that the customer or the client arrived, while arrival date day of month tells us the day, the specific day in a month that the client or customer actually arrived in either hotel or the city hotel or what's the other one? The resort hotel, okay? So what I will be doing, it's something about feature engineering. So basically what I'll be doing is that I'll want to merge, we'll want to merge the arrival date year, the arrival date month, and the arrival day of month together. But there's one caveat that we need to solve. When you look at the arrival date month, you can see that the values are it specify the name, not are not the uh, are not the month in terms of uh, not the what will we say? It's specifying the month itself. For example, July is the seventh month in a calendar year. So instead of using the numeric 7 to represent July, we when collecting this data, it was being represented in form of thing or the month name itself. So before we merge these columns, we need to sort out this column, the arrival date month. So let's first assign numeric values, or and these numeric values will be between 1 and 12 to symbolize the starting month and the closing month in a calendar year. So let's start by doing that. So we are going to let's first determine the values values in arrival date month. So let's first try to determine the values in that column. So df, then just do arrival date, so arrival date month. That's it. After this, we can just do dot unique to that. So when we are done with this, when we execute this cell, you can see that it gives us a list of the values, and these values represent the month of a year. So let's move forward, move the next step, where we are going to be using a dictionary and try to map the month and its position in a calendar year. So this can just paste this here. So we are going to create a dictionary to map months to numeric values. So following that sequence, the sequence in a calendar year. So we created a variable month mapping, and this is our dictionary. So for January, we are going to map that to 1, February to March 3 until December, which is the 12th month of a year. Then after we are done with that, we can then use the map function, this one, to apply the mapping to the data frame. Okay. So for the data frame, we are just targeting the arrival date month column, because that's the column of interest. Then we are not creating a new column. We're just doing something like we're just going to replace, instead of creating a new column, we're just going to replace the values in the original data frame, arrival date month. When we execute this cell again, we can see that the arrival date month, we have now substituted those months to numeric figures. Then after this, we can then move on to the next step, which was all about, for example, if we just do it like this, df.info arrival date month, you can see integer as the data type. So we are done with that. So then move on. Let's move on to the next step, which is about merging those columns together. Okay. So for us to do that, we are going to first convert those columns to a string and then concatenate those columns together. So convert them to a string, then concatenating is just taking this column and merging it to the next one, and take this one and merging to the rest. So what we're just going to be doing is convert, convert this, convert first to a string, then concatenate. So for this, just do this. Then, since we will create a new column for this, so I'll call this column arrival date. And after we're done with this, I can just do this as pd dot. So after we merge these columns, remember, we're trying to form a column that is a date, meaning that we have the year, the month, and the date. So to convert that column, so we will just convert that column into a date time data type. So we can just use the function to date time. Okay. So after this, we can now start merging those columns together. Identify the column and merge those columns together. So the first column is about arrival date year. So the first column is arrival date year. We can just copy this and paste it here. As we said, we are going to convert this column into a string. So we are using the as type, supposed to be as type. And for the as type, str meaning string. Then when we are going to write this date, remember we'll use a separator. That separator will just use a hyphen. So let's say for the year, let's say 2015 hyphen. Okay, so then we add this, another one which is df. Then we add the arrival date column, so arrival date month. Copy this, paste it in here. Then we can also add as type string. Then we're just going to add that hyphen. Then after we're done with that, then we can also do for the date. So df do this and comma. So this one will be arrival date, arrival day of month, arrival date day. Just copy this, just do basically what I've been doing. For this again, you can just do the outside. So dot as type, then str. This is it. So we are adding the arrival date here. Then we are adding that to the arrival date month. Then we're adding that to arrival date day of month column. And we are concatenating them together to form a single column arrival date. Let's say dates like this. Then after we are done with this, remember after we are done with that, we will be converting that column into a date time format. Then after we're done with that, we don't need these other columns because we have done something known as feature engineering. So we have taken columns and combined those columns into a single or a generic column from the original columns that we had in our data frame. So that's another thing. So this is part of feature engineering. Then let's just drop those columns from our data frame because at the moment we can say that they are irrelevant as of now. So when you as type, supposed to be as that. So when we execute this, we can see that we have dropped those columns. They're not available in our data in our data frame. Then I remember we added a new column, the arrival date. So the arrival date, this is the column that we have introduced through feature engineering. And when you are done with that, you can see that the data type has changed. Okay, so the data type for that has also changed. Okay. Okay, so that's it. That's it. So we have done something on feature engineering on how to concatenate a data frame, or how we can merge some some columns or attributes to generate one attribute, one representative attribute or column. Okay, so that's it. Then the reservation status date. Also, this is remember this is you can see the reservation status date. This is also a date column. So again, we are going to convert this column into a date time format. Let's also do that. So convert the reservation status date column to a date time format. When we execute this, you can see that convert the reservation status date column to a date time format. The reservation date status date. We're not changing the name of the column. Then you're using the to date time function to tell us that we are going to convert the values in this column into a data type format. When we print, let's print the data types of our attributes in our data frame. You can see that now the reservation date time, reservation status date, sorry, we have now converted that into a date time format. Okay? So columns with dates, it's preferably work with them in form of dates. So mostly we can find that these columns are mostly, when it comes to time series analysis, for example, then having the data type in form of a date time is quite important for that. Okay. So we have done some quite manipulation of data here and there. Another thing that I would want to change is something to do with the columns. So I'm not impressed with how the columns are being represented. So I'll be renaming these columns, try to provide better names for these columns that are quite descriptive. Okay, so that when someone is going through can easily understand what the attribute on the column in the data frame represent. So I'm going to rename columns. So when renaming these columns, I'm going to be using a dictionary. So I'll use a dictionary for that. So I'll use when renaming this, I'm going to just say use a dictionary. Use a dictionary mapping that maps current column name to provided name. Okay, so we're going to do that. So I'll create a new variable columns. Let's say columns rename. Then from here we create our dictionary. So before we do that, let me just do something here. We can add code cell before this and just print the columns in our data frame. So when we do this, it will print out the columns. So the first column is on hotel. Just copy this and then use the column, and here we can just say hotel type. So we are going to change our name from hotel to hotel type. Okay. Then here use another comma. Cancelled. Just copy this console, then just say that there is a observation console. So we are going to do the same for all other columns. Or if we see that a column essentially needs some change of names. So this is how it will look like. So for example, the lead time, we have just converted this to this, arrival date, week number. So instead of using more words, you just shorten that to arrival week, weekend nights, stay in weeknights, meal type, market segment, distribution channel. So basically, this is how we can just do change the names of these columns. At least we make them a little bit descriptive. Okay. Then after we are done with this, we can use the map function. So here we can just say apply the mapping to essentially rename the columns. When we do this, we can just again use the rename function. So df.name, df.rename columns. So we are going to target this dictionary, our dictionary that we created earlier. So we can do that. Column rename, then do this and say in place. Okay. Then after this, let's do that space. And after this, just do something like df.head. That's it. So you can now see how the columns are now. I think we see that at least we provided some good names for our column attributes. They are now looking okay. If you ask me, they are quite sumptuous. So so that's part of data cleaning. So the next step will be about checking for duplicates. After this, we check for duplicates. When checking for duplicates, I'm going to be using the function df duplicated function. And this is the function I'm providing an argument or argument parameter, say an argument. So for this argument, I'm saying keep equals false. That means that when we are counting those duplicates, it's just going to sum every duplicated row, whether it's the first one or the middle one or the last one. So it's just going to count all those duplicated rows and give us the output is in form of summation of all duplicated rows. So when you execute this, you can see that we have a total of this is 43,117 duplicated rows. So we don't want to be working with these duplicated rows, so I'm going to drop duplicated rows. So for here, we can just say df drop. What are we dropping? The duplicates. We're dropping the duplicates. Then say keep. So when dropping these duplicates, I want to keep the first row of, for example, if column number 56 is duplicated, let's say from column number 56 to column number 60, they are duplicates. When I say we are going to drop the duplicates, but keep equals first, when you specify that argument, is that the column number 56, we're going to keep it in our data frame. But column number 57, 58, 59, and 60, we're going to drop those columns from the data frame. Okay, so keep equals first. Then we can add another argument inside here and say that in place true. In place true. Okay, so when we execute this, we will have dropped those duplicated rows. But and if you want to do some counter checking, you can see that you can now see 0. That means we have successfully dropped those duplicated rows in our data frame. Okay? So basically, those are the one of few of the many steps that you can take or undertake when doing data cleaning. So there are various ways you can do about your data, so that to make sure that your data is as clean as possible, so that the results or the outputs, the insights that you're going to be getting from your data are as conclusive as possible. So that's what we are trying to achieve with our results. Okay. So other things that we can add on under the data cleaning exercise is that we can do something like let's print the unique values for categorical column. If you have unique values, let's see what unique values we are having or we are dealing with for the categorical values in our data set. So the first line of code is all about selecting the categorical columns. Exclude. This is not. So we are going to select categorical columns in our data frame. So in our data frame, you can see that our data frame contains the columns are of different data types. And for the data type object, these are categorical values, or in other words, you can call them as a string. Or, so we are going to do a selection of the categorical columns. When you select these categorical columns, we're going to use the function select dtypes. And from there, we can just include the columns with an object as a data type. Okay, simple as that. Instead of copying and pasting the columns with the object as the data types. So this one, with this line of code, it tries to ease in that process. Then from there, we calculate the frequency of the categorical values in each selected column. So the selected columns are here. So we calculate the frequency of the categorical values in those columns. And for that, we're just using a for loop. For loop will be iterating over those columns and trying to find the frequency. And here, remember, we have created something like a dictionary or a set or something like a list. So that will be storing those the frequencies of the categorical values. Then from there, we enter this for loop that it will be iterating over those columns with the data type object. And then we can then print the frequency count for each categorical column. So for the for loop column, so for column count in frequency count this one, items, the items in that column. Then print, this is just an F string containing information that some information about that specific column. So frequency count for, then we're going to print the counts. So counts will be the count for those unique values in those columns. Then I've just added this print here, something for readability, so that after it has printed information about one column, it's going to leave some space before it prints information about the next column, so that we are able to differentiate the different columns. So when you execute this, you can see that frequency count for hotel type. So hotel type is a categorical values. You can see we have two values: city hotel and resort hotel, and it possibly giving you the number of the count of the unique values under that column. You can see the same for the meal type. You can see the same for the market segment, all the way until, for example, until reservation status. Okay, so you can see the distribution. Okay, so you can see the distribution of the unique values under the categorical columns in our data frame. Okay, so basically you're seeing the count. So when we did this, there is something about the column hotel type. So the objective for this exploratory data analysis, we're going to be comparing city hotel and the resort hotel comparing them with the given metrics. The metrics are just other attributes in our data frame. So we are going to be comparing how city hotel and the resort hotel is performing given certain type of metric. For example, the customer type. So what customer type are mostly attracted to the city hotel, and what the customer type are mostly attracted to the resort hotel. And we cannot do such type of analysis if we have a varying count for, let's say, clients or customers for the city hotel and clients or customers for the resort hotel. So it won't be possible. Even if we do this, our results will be imprecise, something like that, because we are not doing something. Let's say we're not comparing oranges to oranges. We're comparing oranges to potatoes. Okay. For example, when we are calculating the mean, see, when we calculate the mean for the city hotel, let's say if we have revenue, okay, so we want to count revenue or let's say the number of clients or customers are using their facilities. So when we want to calculate a metric that requires the mean, then it will be imbalanced if we use a different population n. Okay, so let's try to equalize this so that we have when you calculate the mean, that's n. The mean, getting mean. When you calculate the mean, let's use this. Let's try to find the calculating the mean formula. And just add here calculating mean formula. Say something like this. So when you calculate the mean for groups, so mean is the x bar, frequency of each class, then n is the total frequency. So if we have varying total frequency and want to compare those two results, then the value of n will be different. When the value of n is different, then definitely we are going to be getting varying results for that metric. So let's try to equalize this so that we will be comparing one-to-one and not a one-to-two comparison. So we'll be doing something known as resampling. So let's do resampling to balance out the occurrences of hotel type. Let's do that. Just do something like this. Convert this to markdown. So resampling to balance out the occurrences of the hotel type. So when you do the resampling, so let's do that. So we can just say hotel type. Hotel type. So hotel type is the column that is containing the hotel type is the column that is containing the hotel type. So what we will do, let's do like city hotel df. So do df, then df hotel type pype, and that's it. We do city. So we're only going to select the values that are city hotel, and then this missing something. This one, add another bracket here, and then we close this with another bracket. So that is for city hotel. You can do again a resort hotel df. So here you can say df into bracket again df, add another square bracket. So here we specify again hotel type for the column that we are targeting, something like that. Then we can and then say resort hotel, and that's it. Then after this, we can sample equal occurrences for each hotel type. Then from here, we can just say something like samples in length, velocity, df. Then and then say length. Then resort hotel df. So basically, let's try something first. It's hotel resort, resort hotel df, supposed to be hotel, okay? So sample equal occurrences for each hotel type now, okay? So with this code, what you're doing is that you're going to randomly select an equal number of samples for both city hotel and resort hotel for further analysis. So here, this code we are trying to select to do something. We are going to randomly say randomly select equal occurrences for hotel type. Okay, so that's it. After this, you can then so balanced city hotel df, and then say city hotel df dot sample n equals to samples random set. So for the random set, you can use any value. Doesn't mean it has to be doesn't mean it has to be 42. So balance, so we can just change to resort hotel dfct hotel. So this one is supposed to be resort hotel df sample and samples. So I think this is it. And after we've done this, we can do concatenation. Data.pd.concat balanced the hotel df again balance result df. And that's it. You can then after this and just repeat this again. Just repeat this. See what we are getting. I'm going to execute this. If that runs successfully, you can execute this again. Then here we can see that we are not getting city hotel and yeah, there. City hotel uh, is something we are missing here. So data.info. Oh, so we need to just change this. It's supposed to be that data.info. Let's execute everything from the start and see if we are going to get the same. We're still getting so we're still getting some error. We need to have let's see, info and see. Then execute this. When you execute this, you can see that we have tried to resample our data. We now have 66,954 entries for each column. And then when we execute this again, let's see if we are going to get okay, now we are getting. You can see now the frequency counts for hotel type. You can see now that we have constrained that to a total of 33,477 entries for each type of hotel. Okay? So that's it. We can also do something again. Let's say the distribution for numeric numeric columns, something like that. So I just use a distribution histogram. So df.hist beans, let's say 50, then figure size, as you can say, let's say 15,10, then plt.show. So when you execute this, basically here we are just going supposed to be hist. Basically here we're just going to be getting plots. These plots will be for the various columns, numeric columns in our data frame. We're just going to get histograms to see the data distribution. And when we look at these columns, the numeric columns in our data frame, you can see how data is distributed in these columns. And from the look of things, you can generally say that in terms of data distribution in the numeric columns in our data frame, that they are not following something known as the normal distribution. We are not dealing with data that is in a normal distribution. Okay. Oh, so that's it. We can also do the same for the categorical columns. So we can also print something like this for the categorical columns and maybe see what they look like. So the first thing is that before we do that, let's do this. We can do something. We can print and first select columns with the data type. So df categorical. So we are going to select columns with only object as the data type. And for the df integers, we are only going to select columns with either integer or float as a data type. Then you can just print all this. So this is another way that you can do. Otherwise, select those columns and see. Okay. So after doing this separation, you can now see the columns with the object as the data type, and columns with numeric columns in our data frame. So you can do that separation. Then from that, we are going to print some pie charts, and this pie chart will show the percent representation of the unique values in each column in the categorical column. So categorical columns are the columns with categorical values. So with this, we cannot plot something like a histogram. We can just use pie charts to show the percent representation, something like that. So the first thing is that I've listed the categorical columns. So just copy these and just paste it here. So you can either do this or just use this line of code. Just use this line of code and just paste it here. So for example, you can just copy this line of code and let's do this categorical columns and change this to categorical columns and change this to categorical such that when we print this, we're going to get something, and we can just again copy this, and we can just paste it here, but let's put it as a comment. So as I said, one of the main ways you can do this is to create a list. So with creating a list, maybe you just want to have a specific set of number of columns in your larger data frame. You don't want every column with the data type as object. So that's why you can use this just to create a list. But if you don't want that, you want every column in your data frame. So instead of this, you just go in with this line of code where you just select every column with an data frame object. So let's see first with this if you're going to get something with this line of code. So after creating your list, you can then move on to calculate the number of rows and columns based on the number of categorical columns and subplots per row. So remember, we are going to plot pie charts that are close to each other in terms of a row and a column. Okay. So for this, I'm specifying that I want the final result to be 4 columns. For this one, you can see we have 1, 2, 3, 4. So we have 4 columns, and in terms of rows, we have 1, 1, 2, 3, and 4. So 4 columns, 4 rows. So here I've specified that I want 4 columns, and for the number of rows, we are going to perform some mathematical calculations. Then for the length categorical columns, that's the number of columns, this one, minus 1. So from here, then divide this by number of columns. So integer division to calculate the number of rows. So we want to calculate the number of rows that will fit our data based on the categorical columns in our data frame. Then from there, we create a figure and a set of subplots. So after getting this number, we're going to create a figure and a set of subplots. For example, we just do this and just see if you will get something. And when you execute this, you can see that we're getting that the number of rows is 3. Okay, something like that. So let me just remove this. So based on this calculation, categorical columns, we're going to sum this 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus number of columns 4, 9 plus 4 minus 1, something like that. So this one is 9 plus 4. Let's see if you're going to get 3. So 9 plus number of columns is 4. 9 plus 4, that is 13. 13 minus 1. 13 minus 1, that is 12. 12 divided by 4, that is 3. That's why we are getting the value 3. So 9 plus 4, 9 plus 4, that is 13. 13 minus 1, 12. 12 divided by 4, 3. So we are going to get that the number of rows in this will be 3. So then after this, we create a figure and a set of subplots. So we have known that the number of rows is 3. So figure and axis, subplots. Number of rows is 3. Number of columns is 4. Then a figure size, this one is 15 in terms of length. Then 3 in terms of 3 by 3, 3 by the number of rows which is 3. So 3 by 3, that is 9. So 3 by 3, that is 9. So we are going to create a figure that is 15 by 9. And then to create our plots, basically we are going to iterate through each categorical column and plot a pie chart. So for index I column in using the enumerate function. So in these categorical columns that we have listed up here, then we are going to select the subplot based on the index of each pie chart. Then plot the pie chart using this line of code. Then set the title of the subplot. Then hide the unused subplots. So for example, you can see in this if we want use this line of code, is that we will get something like unfinished plots. For example, if we are using this, you'll get something like an unfinished plot in this space. Okay, so to avoid that, we are using this to hide any unused subplots. Okay, then we adjust the spacing and everything. So when you execute this cell, it's going to take some time. So this is the result you're getting. As you saw earlier, you are getting 4 rows, 4 columns, 1, 2, 3, and 4. And we are getting 3 rows, that is 1, 2, and 3, third row. So for example, if we do away with this and execute this cell, you can see that let's see, you can see that we are having unfinished plots here. So to avoid this scenario from happening, we can just do away with this and just make sure we include this line in our code such that these plots won't be available. For visualization, it looks like this is an incomplete chart. So if you're going to present data with this chart, it looks incomplete. So it can raise some eyebrows. So to avoid that, let's just do away with that. When you do away with that, at least you get some good, nice plots, and how your unique values in the respective columns are being represented in your data. Okay. So that's it. That's all about data cleaning. So you have seen now the many steps you have taken to ensure data cleaning, some visualization, some grouping of columns, checking for duplicates and all that, trying to do a resampling to balance out our data. Okay, so basically those are the steps that you can take when doing some data cleaning, ensuring that your data is as concise as possible. The next step, which is the agenda of today, which is all about exploratory data analysis. So we are going to start. With the exploratory data analysis. From this, basically what you're trying to do is we'll be trying to find some insights about the data, okay, and some conclusive analysis about that. Okay, so let's move on to exploratory data analysis and see what insights we can find about our data. Okay. So let's begin with the first one. The first thing is that we are going to do a comparison of hotel type and the type of stay. So we're going to do a comparison of hotel type and the type of stay. So this one is good for demand analysis. So we're going to assess which day of the week are more popular for each hotel type. Okay, so that's the major goal that, or not necessarily which day. We're going to assess which days of the week. We're going to assess, say, population of customers during week and weekend. each hotel type. This one is important for when developing a marketing strategy and also operational planning. Okay? So the first thing is will be about grouping by hotel type, calculating the total weekend night and weekend, calculating total weekend nights and weeknights. So basically, that's what you will be doing under this. So you can just say hotel stays df dot. We're going to be grouping by hotel type, body shaking. So hotel type. So you can just do hotel type. So df hotel stays df dot group by hotel type. Now you can use an aggregate function. Provide a dictionary for that. So you can just say weekend nights. So for the weekend nights, we can just do some summation. Going to sum this. And for weeknights, again, you can just do another summation. And when you're done with this, since we are generating a new data series or a new data frame, you can just reset index. Now, there is so you can also rename these columns. Say hotel stays dot column. We're going to rename them. So the hotel type, then after that we can just say something like total stays in weekend nights. Weekend nights and also those days in week night. So when I execute this, getting some error. Says in so doesn't allow columns to be created via a new attribute name. So we're getting hotel type, total stays in weekend, total stays. Let's suggest this, total stays. When you execute this, so that's it. So you can see that the city hotel total stays in a weekend night is about 45,287. Then the nights, the weeknights about 118, 127 is that hotel, this. Okay. Then from here, you can plot this information using bar graphs. So for plotting, I'm using a Plotly because I find Plotly to be quite awesome in terms of visualization, in the sense that it gives you more control of the charts. Okay? So you can, instead of adjusting the code, you can just adjust the charts one way or another, so that you obtain the necessary information that you really want from those charts. So when I execute this, um, getting some error here. So hotel type supposed to be hotel type. Let me just correct something here. This, okay. So this is the output from that. So from the plotting the bar, grouped bar graph, so for our x-axis is the resort hotel. The y's are the column names. So the total stay in weekend night and total stays in the weekend night. Then provide the labels. This is the total stays. Then provide the title for our chart. This and specify that this is a group pie chart. When you want to adjust your chart, you can use this. So if you want to adjust the width of the entire plot, you can play with this. If you want to adjust the height, you can play with this. If you want to adjust the bar gap between one bar and the next, you can play around with this. So this is what we are getting from that. So you need to ask yourself, what insights are we getting from this? In terms of the insights, you can see that generally, let me try to squeeze this together. Try to increase this. So when we look at these columns, you can see that generally, you look at the total stays in weekend night for both city and resort hotel, you can see that it's for the weekend night, it's high for the city hotel. Maybe people like partying during in the city. So we can see that during the weekend nights is that we have a higher population of nights than a resort hotel. Again, when we look at the during the week, you can see that for the city hotel, again it's high. So when you compare that to the resort hotel, you can see that generally resort hotel, nope, nope, nope. Red is for resort hotel. Red generally resorts are supposed to be lower. Generally, resort hotel have lower customers than city hotel for week. Generally, resort hotels have low customers than city hotels for week. For the week and weekend nights, you can see those bars are quite lower than the rest and weekend nights. Okay, so the resorts, they have lower customers compared to the city hotels for both week nights and weekend nights. And then when we look at the weeknights, you can see that weeknights have high population for both hotel types than weekend nights. Okay? So weekday for city hotel, weeknights is about 118,000, and for the resort hotel, weeknights about 106. But for the resort hotel, you can see it's 40 above. For the resort, you can see that is about 40,000, while for the city is about 45,000. Okay? So those are the insights and any other you can obtain from that. We are going to calculate something dealing with the proportionality. So we're going to calculate the total stays for each hotel type. So we begin by calculating the total hotel stays for the weekend night and the weeknight. So for a whole week, so we add this and we add this together to form the hotel stays, okay, as a new column in the variable hotel stays. Then we create a pie chart to represent this information. So basically with this pie chart is that in any given week, so we are summing the weekend nights and the weeknights for city hotel and the resort hotel and see how the proportion of customers they serve in any given week. You can see that in any given week, 47% of people prefer so 45% of this total 45% of this total 6,954. So we are looking at the percent given that, you can see that see that of that population, 7.4% prefer a resort hotel, and 52.6% prefer a city hotel. So in a given week, most people sleep in a city hotel than a resort hotel. We can say that our insight that in any given week, most people sleep in a hotel, in a city hotel, than resort hotel. That's one of the insights that we can obtain from that. So we can move on to the next step, which is about customer type and the hotels. So we are going to see customer type for the hotels, the hotel types. Which customer prefer which type of hotel? So basically, that's the question we are going to answer. So similar to what we did earlier, we're just going to be group our data by customer type and calculate the total weekend and weekend nights, weekend night and weeknights for any given for the different types of customer types. So when you execute this, you can see that for the city hotel, when we look at the customer type contract, you can see the population of contract customer that were sleeping or residing in a city hotel. For the group, the same. For the city hotel, the same. And also, when you cross over to the resort hotel, you can also see the population of the contract customer type that were residing in the resort hotel, the different other types of customers. Then from here, just doing the same thing as we did earlier, plotting a grouped bar graph to represent this information. When we group this information, the reason why I told you Plotly is quite good in terms of visualization is that, for example, I just want to compare only the contract type of customers, the city hotel and the resort hotel. What I'll just do that I will just click on this something like a key. Just click on what you don't want, and they will be deducted from the chart. You're just remaining with the information that you want. So, for example, if I was using, let's say, for example, Matplotlib, then if I just want to select one of only the contract customer, then you need to write a code for that, so that you get a chart for that. But to avoid that hassle, just use Plotly. From this list here, you can just maybe click to deduct information that you don't want from the overall plot. Okay? So if I just want to compare the contract customers for the city hotel and the resort hotel in terms of population, you can see that most contract customer type prefer a resort hotel than a city hotel. So if we look at the transient, we can see that for the transient, you can see that from our sampling, you can see that the transient customers, most of them prefer a city hotel than a resort hotel. So you can do some another comparison, for example, transient and transient party. When you do a comparison, you can see that again, transient party prefer city hotel than a resort hotel. When it comes to group, those are quite few in terms of group. And then group that you can see that they are quite similar, around 269, 273. So in terms of for group as a customer type, you can say that it's almost balancing out. So it's almost hard to tell. So maybe the city hotel and the resort hotel are equally competing in terms of competition for group as the customer type. They are almost head to head, something like that. Okay. So for the insights, some of the insights you can get from this. You can see that transient customers form the majority of customers. So as we saw, when we look at comparing all different customers, you can see that transient customers are form majority of the customers for both hotel types. Then these transient customers prefer city hotels. That one we have said. Majority of the transient customers prefer majority transient, most transient city hotels. So these are we're just repeating the same. Majority of the transient party, contract, and group customers prefer resort hotel. Let's see about that. We're not, we don't want. So majority of the transient party, is purple. Transient party, most of them prefer hotel. We can see that when we do away with this, you can see that actually 9 to 73, 1434, 1657. So we can say that majority of the contracts, the group customers prefer resort hotel. Okay? And these transient customers, and so we can just add here these transient customers and can see transient party customers prefer city hotels, something like that. So that's the insight we can obtain from that. So another thing, and also do another things about lead time comparison. When you look at the lead time comparison among the different hotel types, so lead time is the number of days that elapsed before entering the date of the booking into the PMS and arrival date. I think day the customer did the booking and the arrival date. So that's the lead. Yeah, that's the lead time. Okay. We're trying to compare that lead time comparison among different hotels and see which hotel has higher leading time. Or so, for example, a lead time will tell you will give information in terms of that. For example, let's first that I will explain how can we say that. Okay. Let's leave that for I'll come back to it later. So for the lead time, let's calculate the average lead time for the different hotel types. So average lead time. So basically we are grouping hotel type and the lead time. So we are finding the mean. Then we set the index, provide a new name for that column that we are creating. And from that, this is we print our output. So this is the output. In terms of lead time, you can see that City Hotel has the least lead time with about 77 days lead time. So then for the resort, you can see that the resort hotel, in terms of lead time, you can see it's about 83 days. So for the resort hotel, you expect that if someone is booking a resort hotel, then he books, you can see that books quite early with an average of 83 days. But for a city hotel, when someone is booking for a city hotel, then it takes them, if the person is booking early, then that is the mean is about 77 days before they actually arrive at the hotel. So basically, that's what we are getting with this. Then with this, you can also plot a bar graph to present this information. When you plot a bar graph for this, you can see that for hotel type resort, you can see it's about 83 days, and for city hotel, it's about 77 days. Okay. That's for that. So we can use a t-test, try to see if there is significant difference between these two lead times. Okay, let's see if there is some significant difference. For that, I'm going to use a t-test. So from ipy.star start, we're going to import test. Basically here, so a t test to determine significance of lead times, booking lead times. So you can say, so from SciPy stats, import t-test independent, t-test independent. Then we're going to do something like we're going to separate lead time data for each hotel type. So here we separate lead time data for each hotel type. When you do that separation, you can say that lead time city hotel, lead time city hotel, again, so df again. Then we specify hotel type, so we're getting that. Hotel type, similar to what we did earlier. Then city hotel, are interested with the lead time. Lead just copy this, then do a separation lead time for resort. This one is for resort hotel, so hotel type, city type, resort, it's supposed to be resort hotel. Lead time remains the same. After we're done with this, we can then form an independent t-test. The independent t-test can just do p statistic, then p-value, statistic, then the p-value. Then from here, we recall our function t-test independent is an independent t-test. Then we can do supposed to be lead time city hotel, and lead time resort hotel. Lead time resort hotel. Then after this, we can print our results. The results, say print like test results, test results, then and then print. We're going to print. So and then print. Okay, let's call it p statistic. That will be the t statistic. This one here. We print the p statistic. We can also print the p value. So p value and the p value, none other than this one. This is none other than this. Let's copy this and paste it here. Since this is a t-test, we need to say if there is significant difference. Okay, if there is a significant difference. So if the p-value is, let's say, is less than 0.05, so basically you're saying at 95% confidence level, then we're going to print this statement. I'm going to say print and say there is a significant difference. There's a significant difference in lead time between getting a city hotel and resort. Else, or if now the p-value is greater than 0.05, then this statement does not hold true. So we provide the set statement that holds true. So the opposite of that, basically. So there is there's no significant difference. Basically, for me, this one just means the same. Just copy. There's no significant difference in lead time between city hotel and resort hotel. So let's execute this. So putting this, so you can see that for our t-test results, we're getting a t-statistic of minus 10.13 and a p-value of 4.025777 up to times 10 raised to power negative 24. Basically, there is a significant, so basically our p-value is less than our p-value is less than 0.05. Basically, you can subtract this from 0.05, so it's less than that. So if our p-value is less than 0.05, then this statement holds what? So this statement becomes relevant that there's a significant difference in lead times between city hotel and resort hotel. So if here for our insights, we can say that insights here that the T star statistic value of minus 10.3 indicates substantial difference in lead times between the hotel types. Okay, and the very low value p-value less than 0.05. Just do that. Value, so it confirms this significant difference. So basically, it is a significant difference. So basically, you can say that. So basically, you can say that we can infer and say that. So and say something like that. We conclude that times in types vary. So here we can also say that so this indicates varying in patterns for different in advance. Get varying booking patterns. Booking patterns so are the customer behaviors. The same varying booking patterns and customer. This indicates that varying booking patterns and customer behaviors have and influence. How far in advance guests book stroke reserve their stays in tea and resort. Do that. So the G statistic value minus 10.3 indicates that a substantial difference in lead times between hotel types. The low value of P less than 0.05 confirms this significant difference. And by that, we can conclude that the lead times vary between different hotel types. So with this variation, we can infer that varying booking patterns and customer behaviors have an influence on how how far in advance guests book or reserve their stays in either city or resort hotel. Okay, that's with that. So then we can move on and do something where we at least try to determine customers with the highest lead times for hotel types. What customers do have highest lead times? But just execute this. So we are first going to group the data by customer type and the hotel type, then calculate the maximum lead time for each group. Okay. And so the highest lead type, we are going to group by the customer type, hotel type. Then for the lead time, we're going to calculate the maximum maximum lead time for each group. Okay. So we sort this, then we sort our data by lead time in descending order to find the customer with the highest lead times. So when we group this, so customer type, hotel type, lead time. So basically, we are calculating the group the data by customer type and the hotel customer type and hotel type. Then calculate the maximum lead time for each. So the maximum. So if you want to find the mean, you can just do this. I'm not wrong. When you find the mean lead time, let's let's not jump. Let's first find the max. So the maximum lead time for customers, for different customers. We maximum was for the transient who 737 maximum lead time. Then for city hotel 629 for transient party is. So if you want to view this data set, something, let's see if we can view this data set. The data sets, I'm storing my times, my data sets, hotel bookings. See if we can view this data. So let's open with the Google Sheets. Well, that is loading. So basically, I think you can now see. You can move on, and you can see that transient customers. Those are the customer type with the maximum lead times. The transient was a transient. In short, the customer with the highest lead time was a transient customer, 737. The list was the group about 631, 361. Let's see if this one we can be filter. Maybe we are looking at lead time. Lead time. You can see that we have Resort Hotel is 7:37 the lead time. You can sort by values. So for the values, we go to the highest value. You can see that 7:37 and 7:37 was for the Resort Hotel, and this was this is the type of customer. This was a transient customer. So we're just looking for the customer who the maximum lead time. So for this, again, you can just copy this and then do a reservation status. No, this is not a, not be a reservation status. This one is not supposed to be here. Okay. So we can with the highest lead time. So we can also calculate say the mean lead times for. You can just add this. Let's say mean lead times for current customers. I think this one will be the most appropriate metric to measure this. Then for that, we can just say mean lead time, df to group by mean lead time sorted. We can just change this to mean, and then execute this. So mean lead time, you can see no, getting some error. Mean lead time supposed to be mean. When we do this, you can see that the mean lead time for a contract customer is about 163 days. For transient party is about 115 days. For transient party for resort hotel is 115 days. For transit party for city hotel it's 109. Then we have the contract. The mean lead time for contract for a city hotel is about 47. So that's how you can possibly do that. You can move ahead and plot grouped bar graph for this. Mean, let's try. Let's just copy one of these that we did earlier. See what we can change. So change the mean lead time sorted. Just copy this one here. For the x's, we want them to be trade type or customer type. Let's use hotel type for x's. Then for the y, let's use the lead time. Copy this. Let's use this. And then for the color, we can use customer type. Okay. Then title we can say mean lead times for different customers for different customers for different sales. The label you can just say total bar mode group. Just do away with this. They are not necessary as of by now. We understand what is their use. So the value of y is not the same as the data frame. The customer and this lead time. this one. Now we can get that. So we can see that when we compare the mean lead times for different customers for the different hotel types, you can see that just so for contract, we can now when we compare for the resort hotel and the city hotel, resort hotel and the city hotel, we can now see how the different customers are behaving. Okay? And see the behavior of the different customers based on this information. So that's on that. For the next, we can move on to the reservation status. Do something on reservation status and see what information we can get from that. So under the reservation status, we are going to examine the distribution of reservation status for each hotel type. So for that, we are just going to group the hotel type and the reservation status, and then do this, then plot the graph. By now, I think you have an understanding of what we are trying to do. So we are grouping hotel type and the reservation status for the different see the reservation status for different hotel types. So from here we can see that in terms of for reservation status, we have either cancelled, checkout, and no show. So from the look of things, we can conclude and say that for both city hotel and the resort hotel, most of the guests arrive and do checkout. But for the cancellation, you can see that most of the cancellation happen for city hotels. Okay, most of the cancellation for the city hotels. And for the no-show, maybe remove this. For the no-show, again, you can see that for the no-show, this means that the guest did not arrive. Then for the no-show, we can see that most of the no-shows happen for the city hotel and the resort hotel. I think when someone books for a resort hotel, is maybe quite sure that, but maybe there's other reasons as to why this guest did not arrive. Okay? But most of the guests that did not arrive occurred for the city hotels. So the insights, both hotel types have significant amount of checkouts, but was high in resort, high in city. Supposed to be. So the checkouts was see for the city hotel. Okay. Then what was for the city hotel? Okay. Then both hotels have both hotel types have significant amount of checkouts. Okay. Both hotel types have significant lower no-show cases. They have used significantly. It means we did something like an FTS and over. So we can just say that both hotel types have lower no-show cases. Just say that. But they were listing resort hotels, and city hotels have no cancellation. City hotels have more cancellations. Hotels have more cancellations. Hotels have more. Okay, that's an insight you can get from that. And when we compare customer type and the reservation for the different hotels, Also do that comparison. So for this comparison, compare customer type and reservation for different hotel types. So customer type and the reservation. The objective is to analyze and compare the relationship between customer type and reservation status for each hotel type. So similar to what we did earlier, so we can just group data by customer type, reservation status, and the hotel type, then count the occurrences for that. So this is what this code is doing. And this is just more about plotting, just plotting bar graphs, grouped bar graphs. So with this, we have tried to separate. So the first section is about the hotel type is for the city hotel, and for the next bar graph, the hotel type is for the resort hotel. So earlier on, we were just merging them into one single chart, but this them something like that, so that try to see how the different metrics compare. So again, you can see the reservation status, cancelled, checkout, and no-show. When we try to compare this, let's try compare in terms of cancellation. Which customer type has the highest cancellation? You can see that for the city hotel, earlier on we saw that city hotel have the highest number of cancellations. Okay, so here you can see that again the city hotel have highest number of cancellations. That is one. So we're getting the same thing. And we can narrow down now to see which customer type have the highest number of cancellations. Okay, so maybe if you're doing target marketing, this is where this type of analysis comes in. So you can analyze and see that okay, the transient customers have the highest numbers of cancellation for both city hotel and resort hotel. So maybe you can act by providing a discount for them, okay? So that maybe they are not cancelling out their stays in those hotels. They are followed by the transient party. So also again the transient party in terms of cancellation, they are the second in terms of cancellations, followed by the contracts. And when we look at the contract again is high for the city hotels than this, and for the group, you can see that quite low in terms of cancellation. For the checkout, again, for the checkout, this means that they booked for the city hotel and the resort hotel, and they were guests in those hotels, and they actually stayed during their time and they left. So we can say that these are the people that the city hotel and the resort hotels need to focus more, because these are the people that run the business. Okay, so with this, you can see that for the city hotels, the transit again, they are leading in terms of checkout. They're the people who came in and paid and left, followed by the transient party again. But there's some slight difference in terms of checkout. You can see that in terms of checkout, this is 1514 and this one is 1069. So for the contracts, in terms of checkout was higher for the resort hotel, and it was also higher for the contract. It was lower in terms of the city hotel. Okay. For the no-show, that means they booked, they did not, they were not guests. Again, in terms of no-show, so if you have cancellation is that they cancelled. No-show is that they didn't show up as guests in either resort or city hotel. The transient is leading about 629 customers for both resort and transit. Again, transient party, the same contract, the same. So with this, we just narrowed to see the reservation status for the city and the hotel. This we narrowed even deeper, and we saw the comparison between now the reservation status when we rope in hotel type and the customer type. You can see how the different customer types are behaving in terms of the reservation status. Okay. Then from here, we have at least done some insights that you can obtain from this. Let's do another one that will be dealing. Oops, that will be dealing with something to do with the deposit and the reservation status. When we compare deposit and the reservation status, so what is the objective? What are we trying to achieve when we do this analysis? So with this analysis, we can see that the objective is to compare the relationship between the deposit type and the reservation status for each hotel type to understand how deposit policies affect the reservation outcome of these customers. For the third part, you can see that we are going to group our data by deposit type, reservation status, and the hotel type, then count the occurrences, similar to what we did earlier. In terms of the code, you can see now that as you go deeper into this analysis, most of these things are just recurring. So you don't need to spend a lot of time typing this. You can just copy this, change a little bit of things, and your code is clean, and you can get something from that. So when you do this comparison of deposit type and the reservation status for the different hotel types, so let's go step by step. So when we compare the deposit type, so when we for the no deposit, you can see that it was high in the city hotel, and list for the deposit type for the no deposit, and when you compare the no deposit and the cancellation, you can see that no deposits, there was a lot of cancellation. Again, for the resort hotel, if there was no deposit, there was a high amount of cancellation. So that means that if a customer or if a guest pays no deposit, then the chances of cancellation increases. They are losing nothing. They didn't place a deposit, so they are losing nothing if they do the cancellation. For the checkout, they expect something different. Uh, Again, for the checkout, you can see that again, no deposit, as higher amount of checkouts. Okay. For no refund, again, we're getting some zero. So for the no show and the deposit, you can say again, you can see that no deposit has quite an influence in terms of cancellation, checkout, and no show. So basically, those are the insights you can obtain from that. So I think we will end here for today. We ended at the deposit and the reservation status. So we'll end here for today and pick up tomorrow. So I think that's it for today. And before we sign out, again, I'm really requesting that you subscribe to this channel, the notification bell, so that you get updated every time we post something on this channel. You can also give this video a thumbs up, and if you have something to tell us, please reach us through the comment section. We will try as much as to get back to you. Once again, thank you for your time, and see you in the next session. Bye bye.